Okay, welcome back everybody to episode 7 in our data structure series. So today we're going to talk about a different data structure, one of the most fundamental ones other than the array. So this is what's called a linked list. There are 3 versions that we're going to look at in this series. One is known as the singly, and then there's the doubly and the circular. Now with the linked list, the difference between an array and the linked list is that with an array, the memory is stored contiguous in memory, so each element is side by side within the memory, and that leads to being able to index and say, okay, I want to look at element 5, so it just goes to element 5 without having to look at the other elements. Now with the linked list, everything is scattered throughout the memory, so we have to link it up. That's why it's called a linked list. So we aren't going to be able to index. We're going to have to start at one element and then go through each and every other element. So that's the disadvantage with the linked list. Basically, you have to start at one node and then go through all of the nodes instead of just being able to go to one node. So anyways, we're going to look at the singly linked list today. And the linked list in general uses what's known as a node, and this is just a supplementary class or structure that has 2 fields. It has a data field and then it has a next node field. So the next node field is where we're going to point to the next node. That's why it's called next. So anyways, let's say we have a few nodes within our linked list. So each node, has 2 fields. So this node here would be the first node in our list, and this is what's known as the head node. So that's going to be important. That's not how you spell head. There we go. And this is just going to point to the next node, and then this is going to point to the next node. Then our data field stores some data, so whatever type of data we're storing, something like this, I guess. Anyways, there are 4 main functions that we need. We need to be able to insert data or new nodes into the list. We need to be able to delete nodes from the list. We need to be able to search for data within the list, and we need to be able to traverse the list. So anyways, let's go ahead and talk about these functions. So with the insert, we're going to have to check a few conditions. When we create an object of the linked list class, first off, there's not going to be any elements because we haven't inserted anything. So we're going to have to check first off when we're inserting whether there are no elements, whether there is only one element, or there are multiple elements. So let's just say, for simplicity's sake, that our linked list has multiple nodes within it. Now to actually add another node on here, like I've mentioned, we have to start from our head node, our first node, move over to the next node, and then we can add on a new node like this. Now with the delete, it's pretty much the same case depending on what version of delete you're using. You can have multiple variations of the delete function. So if we want to delete this back node here, we'd have to start at the front, move to the next one, move to the next one, and then delete. So again, this is the disadvantage with the linked list. You have to start from the front and then traverse through each node one by one. Now with the search, it's the same deal here. We're just going to look at each node one by one, checking if the data is there, and then telling the user somehow. Now with the traverse, all we're doing is moving one by one. So this is going to be one of the more fundamental functions. We're moving one by one by one. Anyways, that's what the linked list is. That's how it works. Let's go ahead and look at the code. Okay, so here's my code, my implementation of the linked list. I'm using templates, so everything is within the header file, and then I have my driver function here. So you can see I have 3 different versions of the delete function. You can delete from the back, you can delete from the front, or you can delete a specific position. We also have our insert function here. We have the search function, and then we have the traversing, which is just printing the data. And that's all within this. Let me find it here. Here's the actual class, the singly linked list class, and you can see all of those functions are there. Now there are 2 attributes to this class. We have the head, which again is the front node, and then we have a size attribute, which just keeps track of how many elements we have. Now this class is using the subclass of node, and the node again just holds the data, and then the next node, which is of type node. So it kind of uses itself. Okay, I'm going to have a repository up on GitHub, so I'll leave a link to that in the description of this video, and you can go ahead and look at this code and just see all the specifics of how it's working. Anyways, with C++, they actually have a library already built for the singly linked list. It's called forward list. So if you just include this library, you can use all of the functionality of the singly linked list. But this is just my implementation of it. And let's go ahead and run this code. Okay, so here I'm in the folder and I'm just going to use mingw and use that shortcut that I showed you, pass in the executable name and then the actual files. So again, I put all of my definitions within the header file, and we don't compile header files, so we don't need to worry about that. Anyways, we're just going to compile our driver file. So let's go ahead and execute that, and hopefully there will be no errors. Okay, now we can go ahead and run this. So run me.exe, and you can see we actually have a name attribute for this linked list class. I'll show it to you here. It's actually public. I didn't put it in the private section because it's not that important. This is just differentiating the different singly linked lists that we may have. So we're going to store names within this linked list so we can add some items. Okay, now that we have some items, I can go ahead and use the traverse function to actually print the data. So we're going to do that, and you can see it prints all of the elements. So that's the traverse function. Now what I can do is search for some data with the search function, so 5, and I'll pass in the name Dan, and it'll print out where it is. So it shows me there's the data Dan at position 0. Now if I were to add another element with the same name Dan, now if we look, we have 2 Dans in the list. So if I search for Dan again, it'll print out both iterations of Dan. So anyways, let's look at the deletes. So these do what you would expect them to. If I delete from the back, it's going to delete Dan from the back. So if I print that, you can see Dan's gone from the back. Now if I delete from the front, 4, that's going to delete Dan from the front this time. So let's look, Dan's gone from the front. Now I can also delete from the middle using the delete position function. So I can choose a position. Let's say I want to delete Joseph, so 2, and now Joseph should be gone. So yeah, that's the linked list data structure. The main point of the linked list that you need to understand is that the memory is not contiguous on memory on the actual hardware. So it's scattered, and you have to link it together using pointers. So yeah, definitely have a look at this code. Again, there will be a link to a GitHub repository in the description, and I'm going to do a video pretty soon on how to use GitHub, so that'll be cool. Okay, and it's called a singly linked list because you can only move forwards with it. We have a head, and in our node we have the next node. Now we'll see with the doubly linked list, instead of just being able to move forward, we're going to be able to move backwards through the list and forwards. So with the node, we're going to have a next node, and then we're also going to have a previous node. So that'll take up a little more memory, but it's going to be a little advantageous as well because we can move backward. Okay, so here's the actual documentation on this data structure singly linked list. In C++, again, it's called forward list for whatever reason, probably because you can only move forward. Now you can see all the member functions, and you can go through that and see how that works. Anyways, that's going to do it for this video. Catch you in the next one.
Perfect.